Okay, so the first thing we need to do is in the file I gave you guys, there should be a wall on the class 2 layer because we didn't quite get to this, so hide this. So we need a surface to build our bricks off of. So we can use this. We can bring this surface into our algorithm by using the surface command. So now that it's in there, we can turn this layer off, and it'll always just kind of rest there. And that's where we're going to build our bricks from. It should be on class 2. There's a rectangle already there. Because this, the way this algorithm works, it's a little bit finicky, so you kind of have to adjust each parameter to get the bricks to show up correctly on the wall. So we're going to run through exactly the same settings that's on this one, but maybe I can take a look and we can do that other brick wall, and I think it's a bit more, it's a bit smoother and it's updating. But this is just good for understanding logic and how each number influences the other numbers within your algorithm. So it's a really good place to start. So, okay, so we have this surface, and we need to give ourselves coordinates to line up our bricks. So we can use the surface divide tool and input our surface. So that gives us all these dots, which is going to be too many. So we can use the number slider and make these whole numbers up to 10 for now. So the way it is now, this divides the wall by 2, and this divides the wall by 6. So after we get the whole thing in, then we will take a look at how each one of these influences, but we kind of just want to get the bricks there first. So similar to last class, if we use the param viewer, we can see that we have 7 branches of data, each with 3 points. So there's these 7 branches of data going up, and then we have the points associated with them. So we can also use point list and input our points. And it should show us. So you can see here, if we set this number, that's way too small. So you can see here we have all these points that divide our surface. We have the points listed here, so it's easy to find out where they're from. And then we can understand that we have 7 branches running this way, each composed of 3 points. So the next thing we need to do is we need to draw a line between these points. So we have these polylines, but we need to divide them up so that we can understand where the bricks go this way. So we can use divide distance, or no. But what that needs is it needs a curve to function, so we can use the curve command to change our polylines into curves, and we can and simplify it. So if we don't simplify it, you can see we have 0, 0, and then the number. But if we simplify it, it'll just give us straight numbers, so that's easier for us to work with and understand, just so we're not building up our data trees more complicated than they need to be. So the curve goes into the thing, or into divide distance, and then it asks for us the distance in which we want to divide it, so we can use a number slider with whole numbers. And we can just put any number, but we're going to use 5 as the divisor. So now you can see we have all these points, and these are going to act as locations for our bricks. And we can bring down, we can put in the param viewer, and we can see we have data with 7 branches, and they're still very simple. So now you can see before we simplify it, it goes into a series of 2 series of branches, which is really unneeded. And after we simplify it, it just goes straight into their own data trees. So it'll be easier for us to understand for the rest of the algorithm. So to kind of, if you're having troubles understanding what your data looks like, and you need to help visualize it, first you can use the param viewer. And so in one instance, it'll just give you a simple list of what your data looks like. And if you right click on it, it'll draw a tree and give you a list of what it looks like. So now we have our main set of data, and then it branches once and then goes into our final set of data, so it looks like this. The other thing you can do is you can use points list, or point list, and you can attach your points to this, and for some reason it never inputs the size the first time. So now you can kind of see how the data is arranged within your algorithm. So this is good because it just kind of allows you to understand and see what's going on. So you can be like, oh, I need this point or something like that, and it helps you just visualize where you actually need to grab it from within your tree. No, so if you put a points list, the first thing it asks for is your series of points. Okay. And the second thing it asks for is a size. So I just right click on it and put 1 under number. Yeah. Okay. So on the bottom of this expression deals with the extrusion distance, and the top of this deals with dividing up, creating rectangles around these points and offsetting bricks. So we're going to do the top first, and then we'll do the bottom. So the first thing we need to do is define a working plane, and we're going to work in the XY plane, which is the regular world plane, but we still need to define it. So you can find that in vector and plane. There's XY here, or you can type plane XY. So we just want to attach that here so all our points work within this plane. And you're going to get this because what it does is it draws a plane on all these points. So it's best just to turn the preview off so it's a little bit easier to understand. So the next thing we need to do is we need to use a list length to define how long define the size of our list. So I'm going to keep a panel open here and a param open here so we can kind of just keep on looking back and understanding what's happening. So you can see here right now we have 7 branches, each containing 1 point in it. Yeah. But what we want is we want those to all be grouped together, so we can use the flatten command, and then it'll put these all on the same branch. And so now we have these all together, and we can use the dispatch command. And what that's going to do is it's going to divide our list into A and B. And so we can think about, if we're having a series of alternating bricks, A will be one level, and then B we want to shift over. So we have A and we have B. And we need to combine those so that they get divided into this list. So if we look at A right now, it's 7 numbers, and if we don't flatten it, it's divided. So there'll be 7 numbers here and 7 numbers here, because there's not a single list for it to graph. So what we need to do is we need to flatten it, and then it'll be able to graph our list into 2 different lists that we can work with to divide our data. So similar to last class, all we're doing right now is we still haven't seen any change in this structure. What we're doing is we're just manipulating data and trying to arrive at an outcome that gives us one series of rectangles at one point and one series of rectangles shifted over slightly. And so so this is kind of where it's tricky, and you just have to work through this process, and in the end we can visualize and reassess what's going on. So just bear with me and bear with the process. So next we need to use the repeat command. So we just want to repeat the objects that we're using. So it'll ask for a list, or it'll ask for a length of the pattern, and it'll ask for data. And so all we want to do is work on this, the length. And that's for both of these. And we will need to simplify both of these. So these are staying yellow because we need to define what's happening with our data, or the pattern that we want to put in. So under here, there's set data item, or there's set multiple data items. And what we want to do is we want to say, for the first, we want to set a pattern up so it'll take some items and not take other items. So we want to set the first one to true and the second one to false. So that means it'll take the first item out of each one of these. I just need to double check what I did. Yeah, so if this one is true and then false, it'll take the second point. And so what we want it to do is, on the second list, we want it to take the second point. So we need to switch these. Yeah. So we have our list. We've compacted our list so it's all our points combined, and then we've divided our list into 2 different streams. So we have the A stream and the B stream, or the offset and the non-offset stream. And so then what we need to do is we need to tell our algorithm that we want the first stream to grab every other point, and the second stream to grab the first point, or sorry, vice versa. So the first stream to grab every point, and the second stream to grab every other point. So what we do is we use this repeat data command, and we add our lists to each one. And then we can set the data items, so what it uses to grab those items. And so we set it to true and false. So it'll go through this pattern through all the numbers until it's called or grabbed every single piece of data that we put that's within the list. So we set this one true false, and we set this one false true, and so it'll grab opposing data for each set of lines. Okay, so now we need to turn this data into usable lists, so we can use the path mapper. And we're going to need 2 of those, 1 for each one. And I'm just going to want to show you panel param viewer. So if we don't simplify this and we put this in, you can see that it's created four branches with true, false, true, false, true, false, true, false. And if we look at these ones down here, it says false, true, false, true, false, true. So now we've set up a way to manipulate our data that's driven by a true or false statement. But what we want is we want to use the path mapper, and the path mapper just wants to read through this list once. So if we use the simplify command, it'll just reduce the complexity of our data tree and allow us to work on the same level. So the top equation is going to take our source, which is A. So this is similar to last class. And the target is just going to be A times 2. And this one down here is going to be the same thing but plus 1, so it shifts it over. So now that we have these 2 data streams, what we want to do is we want to combine them. So this just needs to be simplified. Yeah. So now when we combine them, we run through a list that combines this set of data and this set of data and its manipulation. So what's going to happen is we want to look at this data that we've produced that gives us our brick pattern, compare it to our original point data, and then whatever's left over is going to be the points that are going to build our bricks. So we can use the call command, call pattern, and our pattern is based off of this data, which is seen here. the points that we want to use are created from this plane. So you can see that it takes these points and gives us 25 points. So we started with 49 points, and it gives us 25 points. So it's the combining of this, these two data sets, the true, false, combine will give us, and when we put those two together, they create a pattern for us to call all our points through this, through the planes we created at this first step. So if we look at this data, you can see that it's slightly different, and so that will create our brick pattern. So you can see there's a list of 4, and then there's a list of 3, there's a list of 4, and there's a list of 3. But our data tree is still simple and looks similar to where we had it at the start. So the next thing we need to do is we need to create a series of rectangles around each one of these points. So we can use the rectangle command, and our points are from this list. So you can see we have a series of rectangles that are formed around our points now in a brick pattern. But we need to create, we want them to actually touch, so they need to be derived from this distance, because we're baking bricks, so they're all going to be half or a size that relates to the other sizes. So using the domain, the construct domain. So they're both going to be 5. And that's going to fit into X. But what we want is that A is going to be defined by an expression. So it's going to be X divided by 2, I think. Does that make sense? Times 2. So when we do X times 2, you can see that it's twice the length between these points. So now they're starting to connect together. So the last thing we need to do is we need to extrude these rectangles upwards. And to do so, we need to use our points and define those points moving up. So it's X times 2. Yeah. So now what we want to do is we need to finish it off by these commands. So what it asks is we want to flip the matrix so our points are being extruded up. So we can use the flip command on our points, and then list items, list tree. List item. So now what we're doing is we're asking for the distance between our points. And so this distance is created by the distance between points. And so we can use the distance command. then finally we need to give it a vector for it to move about, which is the z vector. We need to simplify this. And so there's somewhere where I went wrong, I think. I messed up the expression somewhere. Oh. So I guess that makes sense. You want it to be the inverse of your number rather than messing around. So yeah, my mistake was here. You want the expression to be the inverse, or the domain to be one side is x and the other side is the other side of x, so the inverse of x will give you where your bricks are supposed to go. So now you can see you can start to mess around with the size of your bricks depending on your sliders. So list item will give you a list of all your items, and if first it'll give you your first item, but if you want your second item, you can zoom in and just click the plus. Yeah, and then it'll measure the distance between the first item and the second item on that list, so this point and this point, and then it'll give us our distance of which we want it to extrude. Okay, where's everyone at? Working? Okay.